be upon you, my dear students in grade 11. Today we will continue our lesson, which is polynomial functions. At the end of this video, students will be able to find the sign of a function graphically, show that the equation f of x equals to 0 admits a unique root or roots on its domain of definition by using the table of variations or graph. Solve graphically the equation f of x equals to m. Before you start, please prepare the following materials: textbook, pens, draft papers, copybook, calculator, and ruler. Now we will start by the first objective in this video, which is sign of a function. F of x is positive if and only if c is above the x-axis. F of x less than 0 if and only if c is below the x-axis. F of x equals to 0 if and only if c cuts the x-axis. Example: c is the representative curve of a function f defined by the following expression. Solve graphically. Part A. This expression equals to f of x, that is, f of x equals to 0 when c cuts the x-axis in these points, thus for x equals to 1 or x equals to 3. Part B. This inequality means that f of x less than 0 when c is below the x-axis. Thus, for x belongs to the open interval 1, 3. Part C. This inequality means that f of x greater than 0 when c is above the x-axis. Thus, for x belongs to minus infinity 1 union 3 plus infinity. Application. Please stop the video, then solve this application. Now we will start by the second objective in this video, which is number of solutions of the equation f of x equals to 0. We have two ways, graphically or by using the table of variations of f. First way, to determine graphically the number of solutions of the equation f of x equals to 0, find the number of points of intersection between c and the x-axis. C is the representative curve of a function f. Determine graphically the number of solutions of the equation f of x equals to 0. As we said, we must find the number of points of intersection between c and the x-axis. C cuts the x-axis in 3 points. Thus, the equation admits 3 solutions. Part B. Solve in 0, the equation f of x equals to 0. As you know, solve means that you must determine the value of x satisfying this equation. In 0, c cuts the x-axis in this point. Thus, x equals to 1. Now, we will go to the second way in order to determine the number of solutions of the equation f of x equals to 0 by using the table of variations. Property. The equation f of x equals to 0 admits a unique solution over AB if f is continuous on AB, f is strictly monotone on AB, f changes its sign, or f of a times f of b is negative. Example: consider the adjacent table of variations of a function f, defined by the following expression. Show that the equation f of x equals to 0 admits on 0, a unique solution alpha such that alpha belongs to this interval. Let us prove the 3 conditions. First condition: f is continuous on minus infinity plus infinity. Do you know why? Good. F is a polynomial function. And so, on 0, 2, F is continuous. Second condition. Do you remember what is meant by strictly monotone? Correct. Strictly monotone means strictly decreasing or strictly increasing. On 0, 2, F is strictly decreasing. Third condition. On 0, 2, F changes its sign from a positive number to a negative number. The three conditions are satisfied. Thus, the equation f of x equals to 0 admits a unique solution alpha on 0, 2. Wait, we should complete the question. We must prove that alpha belongs to the interval 1.34, 1.35. We should prove the following three conditions. Since the interval 1.34, 1.35 is subset of the interval 0, 2, the first two conditions are satisfied. Thus, it's enough to prove the third condition. We can't see that f changes its sign on the interval 1.34, 1.35. So we will use this way. F of 1.34 times f of 1.35 is negative. Thus, alpha belongs to this interval. Thus, f of alpha equals to 0. Please go to the table of variations and add this result. Later on, it will help us in studying the sign of f. Application. Please stop the video, then solve this application. Now we will talk about the last objective in this chapter, which is number of solutions of the equation f of x equals to m. To determine graphically the number of solutions of the equation f of x equals to m, find the number of points of intersection between C and the line of equation y equals to m. Example, C is the representative curve of a function f. Determine graphically, according to the values of m, the number of solutions of the equation f of x equals to m. Let D be a line of equation y equals to m. As we said, we must find the number of points of intersection between C and D. This is the line D of equation y equals to m. As you see, if m less than -1, C and D do not intersect. Thus, the equation doesn't admit any solution. If m equals to -1, C and D intersect in one point, thus the equation admits one solution. For m greater than -1, as you see, C and D intersect in 2 points, thus the equation admits 2 solutions. Application. Please stop the video, then solve this application.